draw diameter AEG. Okay, so that's going to be the zenith line, right? At right angles to this in the plane of the meridian, draw GKZN. So the plane of the meridian being, your particular longitude point with the North Pole creates a cross section of the Earth, which is a plane, right? You can think of the plane through the, where are we looking? Here's the North Pole, let's say, and you're here. So then this circle going, this is a meridian circle through where you are on the Earth and the North Pole, and that's at an angle to the board, right? So that plane where we rotate it around the circle is this circle, and that's the plane of the meridian. Clearly, this will be parallel to the intersection of the horizon and the median, meridian. Now, the whole Earth has, to the senses, the ratio of a point and center to the sphere of the sun. So that, the sphere of the sun is this meridian circle, essentially. Or you can think of it that way in this diagram. Now, since the whole Earth is, okay, so that the center E can be considered as the tip of the gnomon, and let us imagine GE to be the gnomon, and the line GKZN to be the line on which the tip of the shadow falls at noon. Draw through E the equinoctial noon ray. So that's BE. Extend it to the other side of D, and then extend it to the point Z on this line, right? So BEDZ represents the equinoctial ray, and HE theta K represents the summer solstice, and GZ, LEMN, the winter solstice ray, right? So that's this one. And GK then will be the shadow of the summer solstice, GZ the equinoctial shadow, and GN the shadow on the winter solstice, right? So that's going to then, if you were to divide up, on your sundial, this this would be the extent of the shadow on your sundial, right? And you would say, well, here's where either March 21st or September 22nd, you'd be here depending on which way you're headed, right? And then just sort of mark off proper intervals to say what day of the year it is, right? I guess 365 equally spaced? Well, not equally spaced, right? That's a good question as to how you would space that. Because clearly the shadow is growing faster during the winter than during the summer. It's shrinking. So this is not the midpoint, right? So the equinox point is not the midpoint of this line. But that doesn't become an issue here yet. So since arc GD, which is equal to the elevation of the North Pole from the horizon.
Are you on the dot?
You see GD on the
Okay, I have all the
slide
pictures in there.
Yeah.
You're welcome to take more.
So we know that this, it's 21. Yeah, 23, 51, 20 is the tilt of the Earth. And so that's also going to be this measure here, right? Now, we know that, what do we know? We know CEF is, okay, so we have a right angle here, right? So, let's see, we've got a couple of right angles. So we'd like to know, we know that CEF is complementary to FED, right? So let's write that out. So CEF plus FED is what? see those two angles here? CEF is 36 degrees, and FED is this angle here, right? And how do we know what that is? Well, BD is the equator line, right? And that's perpendicular to the North Pole line. So these together make that CED right angle, right? So this has got to be 90 degrees. And similarly, we can say that GED plus FED is also 90 degrees. So CEF is complementary to FED, and GED is complementary to FED. That means that angle CEF is equal to angle GED, right? So this angle here is the same as, GED is here, right? So this is also 36 degrees. And we know that this is 23 degrees, 51 minutes and 20 seconds. That's the tilt of the Earth, the obliquity angle. And so that allows us to determine that this angle here, angle GEK, is going to be angle GED minus angle KEZ. And we know that this is 36 and this is 23 degrees, 51 minutes and 20 seconds. So how do you do the subtraction? We're going to write this over here. So we want to subtract 36 degrees, 23 degrees, 51 seconds, and 20, minutes and 20 seconds, right? So you have to do a little regrouping, right? So you take one of these degrees and you trade it for 60 seconds, right? 60 minutes, I keep screwing that up. Right, so 35 degrees and 60 minutes is the same as 36 degrees, right? Oh, but then we have these seconds to deal with. So let's take one of these minutes and trade it for 60 seconds.